Okay, today we're going to learn about independent and dependent variables and what that is going to look like for us in class. First, we're going to start with some definitions. So we've got a variable. A variable is an object, time period, event, or other thing you are trying to measure. And make sure that you are writing down all the definitions I'm going over. Okay, we can have independent and dependent variables. And we typically represent variables using letters because they are unknowns. So we don't know their value. We have to use something to represent them. So make sure you've written all of this down for variable. Our next definition is independent variable. And we talk about the independent variable and we label it with X. Okay, the independent variable is the variable that stands alone and is not changed by another variable. Key thing here, it is not changed by another variable. Some examples of an independent variable would be somebody's age. You know, nothing affects their age except for when they are born. So nothing controls how old they are. How many hours someone rents a boat. You choose how long you rent a boat. And then how much you earn per hour. Okay, how much you earn per hour is not necessarily going to be affected by, what the weather is outside. So it's independent of other things. And the independent variable is responsible for changing another variable. It is what causes the change in the relationship. Okay, next definition is the dependent variable. And we denote the dependent variable with Y. So the dependent variable is the variable that depends on the independent variable. Some examples of it would be the cost of renting something. So depending upon how long you rent this item, that's how much your cost is going to be. Depending upon how many hours you work, that's going to be the total paycheck that you get. Depending upon how long you're traveling, determines how far you're going to travel. So your dependent variable changes in response to a change in the independent variable. So if the independent variable changes, that means that your dependent variable is going to change because it depends on the independent variable. Okay, we also need to write down about additive versus multiplicative relationships. We've covered this already, but we're going to do a little refresher here. So additive, if it's an additive relationship, you are adding the same value to your independent variable each time. And that looks like y is equal to x plus a, where a is what you're adding each time. So I have an example here of an additive relationship. So whenever you're trying to find out what the relationship between x and y is, you look at your x and you try to figure out how you get to y. Well, there's a couple of ways here. I could take 1 and add 6 to it to get 7. Okay, so 1 plus 6 gives me 7. Let's check that out here. If I take 2 and I add 6 to it, do I get 8? Yeah. Here, 3, do I add 6 to it, do I get 9? Yes. 4, if I add 6 to it, do I get 10? Yes. So our relationship here is y is equal to whatever your x is, and then we saw that we added 6 each time for our x to get our y. So it's x plus 6, and that's going to get our y. And on a graph, so if you were to see this graphed out, it does not pass through the origin. So this is one of those ones where here's your graph, this is x, this is y. It starts right along that y-axis. It doesn't start right down here in the corner of the origin. Okay, next kind of relationship is multiplicative. So in a multiplicative relationship, you are multiplying the independent variable by the same value each time. And that looks like y is equal to k times x, where k is the number you are multiplying by each time. So we look again, we look at x and we try to figure out how we get y from that. So 1, what would I do to get y? I could add 6 like in our previous example, but let's see, if I do 1 plus 6, that gives me 7. If I do 2 plus 6, does that give me 14? No. 2 plus 6 is 8. So I know that it's not adding 6 each time because it doesn't work for every single entry in the table. We need to go back and look. 1, I could multiply it by 7 and get 7. So let's see here. If I take 2 and I multiply it by 7, what do I get? 2 times 7? 14. That's what I'm supposed to get. If I take 3 and multiply it by 7, I get 21. 4 times 7 gives me 28. 5 times 7 gives me 35. So we can see that every time to get y, we have to take our x and multiply it by 7. So you write that as y is equal to 7x. Whatever you're multiplying the x by goes in front always. And if you were to see this on a graph, you would see that it passes through the origin. So it would look like this. So here's your x and y. It starts right there in the corner and goes from there. So passing through the origin for multiplicative, not passing through the origin for additive. And sometimes you will be asked to describe the relationship between the independent and dependent variable. When you are describing the relationship between the independent and dependent variables, you are actually finding the rule or the equation for the relationship. A key thing to do here is take information from graphs and put it into a table. So sometimes they'll just give you a graph, and in order to get your rule, you will need to take the points from the graph and put them into a table to look at it that way. And then we are examining what happens to x in order to get its respective y value each time. So we're seeing, am I going to add something to x, or am I going to multiply x by something to get my y? So now we'll do an example. So example 1, Darwin is riding his bike at a constant speed of 10 miles per hour. The distance he has biked each hour is given below. And they want us to identify the independent and dependent variables, then determine if the relationship is additive or multiplicative, and then describe the relationship between the independent and dependent variables. So we're determining what the variables are, telling if it's adding or multiplying each time, and then giving the rule, so finding that equation that describes it. So we look here. You got time and you've got distance. Think about it. Does your distance depend upon the time you're riding the bike, or does the time you're riding the bike depend upon the distance? It makes more sense that the distance depends upon the time. So since the distance is depending upon something else, your distance is the dependent variable. And since the time doesn't depend upon anything, that is the independent variable. And usually if you have time, time is most likely your independent variable. Independent variable. Okay, so there's A. Now we're going to look at B. We have to determine if it's additive or multiplicative. So we're going to look. You look at each x value. So we decided that time was independent, so it's x, and y, your distance, is your dependent. So you look, how do I go from 0 to 0? Well, I could add 0, or I could multiply by some other number. So 0, 0, we can't really figure out much from it. We have to look at the rest of our table here. Now we look here. 1, how do we go to 10? Well, I could add 9, or I could multiply by 10. Let's look at our next one here. If I take 2 and I add 9 to it, am I going to get 20? No. If I take 2 and I multiply it by 10, will I get 20? Yes. 3 times 10, does that give me 30? Yes. So we can see that we have a multiplicative relationship. Number 1, because it's going through the origin, 0, 0. And number 2, you take your x value and you're multiplying it by 10 each time. So it is multiplicative. And we've also found out our rule. So we take our x and we multiply it by 10. So y, the distance, is equal to 10x, 10 times x. here's our next example. Now, I need to put the graph in really quick. So if you give me just a second. Okay, so we have the graph below shows the cost of renting skates at the ice rink. And we are to identify the independent and dependent variables. We are to determine if it's an additive or multiplicative relationship. And we are describing the relationship between the independent and dependent variables. So along here, our x-axis, this is the time that skates have been rented. And along your y-axis, that's going to be the cost to rent your skates. So we're looking here. What I said before, we have to take our information and put it into a table if it's in a graph here. So you just get some points. So you have your time, and that's our x, and you have cost, which is your y. So at 0 hours, it costs 50 cents to rent skates. So if you rent them for under an hour. If you rent them for 1 hour, then your cost is $1.50. If you rent them for 2 hours, shows that our cost is $2.50. And if you rent them at 3 hours, it shows that our cost is $3.50. So we have our information now here in our table. We can go ahead and do part A, identifying the independent and dependent variables. Automatically, always look at your x. Whatever your x-axis is, the horizontal one on the bottom, that's your independent. Whatever the vertical one is, the y-axis, that's your dependent. So A, we have independent. That's going to be our time that the skates are rented. And then our dependent is going to be the cost, because depending upon how long we rent the skates determines our cost. So now part B, determine if it's additive or multiplicative. Well, looking at this graph right away, does it go through the origin? No, it doesn't go through 0, 0. It goes through the point 0, 0.50. That is not the origin. The origin is 0, 0. So since it does not go through the origin, it is an additive relationship. So now we're going to use that information to look at our table here and figure out what are we taking and adding to x each time. Well, how would I go from 0 to 0.5? Well, I would add 0.5. So let's look here. If I take 1 and I add 0.5 to it, don't I get 1.5? Yes. 2 and I add 0.5 to it, don't I get 2.5? Yes. And again, 3, if you add 0.5, you get 3.5. So to get our y, we take our x and we add 0.50. And I'm keeping it with the 2 decimal places because we're dealing with money. Okay, so the cost to rent your skates is how many hours you've rented them plus 50 cents. Okay, so that's how we do that one. When you have your graph, you have to get all your points from your graph, put them in the table. Look at your axes to tell you independent and dependent. Look where it crosses the y-axis. If it doesn't go through the origin, you automatically know it's additive. Then you use your table to get your rule. All right, so now this is going to be your one to do on your own. It says to show in your notes, okay? So you need to write all this stuff down. A boat is traveling at a constant speed of 5 knots every hour. And they want you to complete the table. So you figure out, look, it's got the time, it's got the distance. You got to fill this in. And yes, I need to see a table in your notes. Then you have to tell me what the independent and dependent variables are in this relationship. And then you've got to describe the relationship, which means to find your rule. So I need to see y equals whatever you think the rule is. Okay, finish this up and I will check it in your notebook tomorrow. Bye.